Testing, testing. 1, 2, 3. Testing, testing. Hello. Hello. Okay. All right. Hello everybody and welcome once again to this, your favorite class in the entire universe of all time. We're going to be talking about Python again, so that should be no surprise to anyone. How's everybody doing today? Hope you guys are doing okay. You guys all psyched for election day in the States? Oh boy, it's gonna be an interesting one. You know, it's kinda, it's like, oh, let me think of my password. There. Yeah. Holy smoke, eh? It's like, I don't know, like this year, I've really, like, sort of distinctly had this feeling of having, like, living through history, you know, which is, like, it's interesting because I don't, like, sure, stuff was going on, like, 4 years ago, but it didn't necessarily feel like a historically momentous time in, you know, humanity. It kind of felt like things were kind of, you know, a little dull and humdrum and not, you know, then, you know, not much was going on. But holy smoke, has 2020 just blown everything out of the water, eh? Like, you can no longer be accused of being a person who didn't live through history. Like, your grandchildren are gonna ask you about this year, I feel. Like, we are supposed to ask our grandparents and great-grandparents about the war, you know? Although that's, you know, it's getting to be, you know, the World War II vets are getting to be pretty old, so, you know, ask them about it while you can, I guess. Anyway, we were talking about testing on exceptions. Very good, very good. No matter who wins, we all lose, yeah. Yeah, I mean, like, us up here in the Great White North, we have the advantage of not having to care too much because, you know, it's not our country. As much as the decisions that the United States makes affect, you know, everybody to some degree. Yeah, we kind of get to sit back with our popcorn and enjoy the show a little bit more than Americans who are like, right, you know, this is sort of their lived reality, you know? But yeah, it should be an interesting one. I know my wife has to work this evening, and she's like, I'm so sad that I can't just sit on the couch with you and watch the fireworks tonight. It's, you know, it's gonna be a fun one. But anyway. It's kind of awful in some ways, but whoa, whoa, whoa. I don't want private browsing. I want this. There we go. A more professional prof would have had these slides loaded beforehand. But, you know, I feel like there's something gained in the class with our impromptu chit-chat, you know. Anyway. So, we had just entered into the subject of debugging. And debugging is a whole thing. It's a process. There are several approaches to it, but every approach to debugging hinges on the idea that you should know stuff about your program, right? In order to be able to debug a program, you need to know its inner workings. You need to see inside of its mind. You need to You need to allow the algorithm itself to envelop you. You must become the computer. Incidentally, I'm not using this mic today. I'm using the mic on my laptop because apparently it's higher quality, but I'm keeping this on, the headphones on, because my head feels naked without them. So this is mostly a comfort thing, I think. Also, it keeps my hair in place, and I need a haircut, so there you go. Anyway. Yeah. So yeah. At the end of class yesterday, I showed you guys a website, which I think I'm going to show you guys again and sort of maybe even do a running example in, because it's super useful. Python tutor. Visualize Python. There we go. And look at all of these. So if you were wondering, oh, this is a great profiler, but does it also work for my language? You know, when you guys are doing languages other than Python. Like, for example, C. Oh boy, that would be a cool one to know. C++ even. So this is what's called a code profiler. This is a tool that allows you to view the values of the variables that in your program as your program executes. This is a really cool tool. It's not quite as good, I think, as some of the other ones. Like, you can find lots of programs that do similar stuff to this. This one seems to lack breakpoints, which is some people consider breakpoints to be like the ultimate in useful debugging tools, but we'll get to what a breakpoint is. So anyway, if we, for example, pull in a program, like, for example, this one that we were working with previously. Copy that. This is the program with a bug from earlier. Paste her in there. Get rid of this. There we go. There we go. There we go. Ba-da-ba-da-ba-da. And then we run max product on 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. This was the code from earlier that had a bug. Visualize execution. Indentation error. What? Fake news. Oh. There we go. There we go. So, you just fixed the following error. Thank you. So, what this thing allows you to do is you can actually pull on this slider and see how the data inside of the function changes as time goes on. So let's step through this code. We're not going to step through all 257 of these, but, you know. So we start off initializing the global frame. We initialize the max. We are initializing the max product function in the function definition. Oh, hey, you can set breakpoints. Then, when we invoke the function call, we are stepping into the function. Max product is added to the call stack as a stack frame. So there you go. And its input, s, has been given the value listed here. This next line initializes max product to 0. We then enter a for loop. I is initially 0. We have then an initialization of product at 1. And if you'll notice, if you click on the line number for any of these instructions, you can see where in the timeline each of these pieces of code is actually executed. So, we then enter the second loop. J is initially 0. If product is less than max product, we calculate the product. It's originally 1. That definitely passes, so max product is updated to 1. We then go through, product is 2, max product is updated, and it goes on and 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 on until j is 11. And then all of these guys reset, but the max product remains product. It remains at its previous value. This is the first sort of high score that we hit. On the next iteration through, you can see we reach a higher value. So max product gets updated, etc., etc. And you can pull through this algorithm and watch it update max product. And you can even like look for particularly the place where max product is updated. So you can notice that when we are here, that j is sort of, we are stopping at I equals 5, j equals 11, right? So this is okay, except for the fact that 11 plus 5 is 16, but we have 18 things here, even accounting for the fact that this is 0 indexed. We should be hitting 17 as the maximum value, not 16. So that's where we can find out where our error is. Arguably, this bug might be easier to find with a test case rather than using a debugging profiler like this, but you can see how this would be useful, right? This is an alternative to endless print statements, because you can just watch what's going on over here, rather than, explicitly having to get the program to vomit up this information itself. So yeah, it's a cool tool. You should use it. Right. So debuggers are usually integrate with an editor. So if you're using VS Code or something like that, you'll probably have a pretty decent debugger built right into it. And it is a way of keeping track of the internal state of a program as it's running, as we just demonstrated. We can step through each line of source code one at a time, and we can set breakpoints. Now, the Python tutor tool does not use breakpoints. Rather, you are able to highlight points of execution while running the code. In a sort of more nominal debugger, what a breakpoint is you would click a line of code, and whenever execution reached that line of code, execution would stop, and you would be able to look at the variables. This is probably a little bit better for larger segments or larger programs, because you can imagine if, this is a relatively small program. If we were running a huge program, this little slider just wouldn't cut it in terms of being able to navigate your program. You'd have to be able to say, okay, run as normal up to this point, and that's what a breakpoint is. So we can set breakpoints. Run the source code until it reaches a certain line of code, then pause to let the developer inspect it. There you go. So there's also idle. Idle is in the integrated development environment for Python. It is built into all Python installations, and you can run it by typing idle3. Let's try it out. Idle3. Could not be found. Okay. Well, there you go. This looks like a Mac thing. So in idle, you can see this is a similar sort of thing, right? We've got our code. We've got a Python shell operating as well. And then we have the debug control, which allows us to step through the statements one at a time, and we can see how the variables are being updated as time goes on. In the same manner. So yeah, debuggers. They're really useful. You should use them. Oh. So, having talked about that, Um, I promised Mark that I'd talk to you guys a little bit about a particular. Ooh, okay. I have a question about breakpoints. What happens after the breakpoint has been reached? You'll have some controls at the top, where you'll be able to step to the next. You'll be able to step through the next few statements, or you'll be able to play. It's kind of like VCR controls, except you know on how on DVD players there's like this step button that allows you to step through the individual frames of a movie, rather than using fast forward and rewind. It's kind of like a DVD player control if you removed fast forward and rewind and just had play and step. So, hopefully that answers your question. So, Mark asked me to relay some information to you guys because he's been getting quite a large number of people who felt like they were not being marked fairly on the test, particularly as it concerns the quicksort function. So I kind of suspect that probably the people who are, having a problem with this may not be the people who are watching the streams concurrently. That's just it's just a hunch of mine. But essentially, what's going on with the quicksort function is a lot of people decided that, there were so basically answers to the quicksort function landed into two categories generally. There were the people who sort of either correctly or incorrectly attempted to implement the quicksort function as described in the question. And then there were people who decided, oh, he just, I don't have to use quicksort, I can use any sorting algorithm, and, because it's sorted, that'll be fine. Despite the fact that you were specifically warned against that in the question. I said something like, if you use, Python's inbuilt sort function, you won't be happy with the results. I guess people underestimated our tenacity in terms of being able to actually check that you were using the quicksort function. But quicksort itself is a very specifically defined function. It has a specific number of execution, as a recursive function, it has a very stable number of recursive calls that it would go through given, a particular array. So we were not only counting whether or not the array was sorted when you were finished with it, we were also counting for the correct number of recursive calls to the quicksort function. This is actually a trick that we often use when marking recursive functions, because, while, the basic problem is that it is always possible to express a recursive function in a non-recursive fashion, right? Anything you can do with a recursion, you can do with a loop. But if I'm trying to test you to see if you are answering the question as intended, that is, with a recursive algorithm, one of the ways in which I can do that is I can create a decorator class that counts the number of times the thing calls itself, which is how we were telling how many times your quicksort functions were calling themselves. And we were using the number of times the quicksort function was calling itself as criteria for the correctness of the question. So some people didn't like that their implementation of a sorting function other than quicksort didn't result in them getting the marks for having implemented quicksort. And a few of these people were not especially kind to Mark, who had the unenviable position of having to point out to these people that their questions were wrong, right? That they didn't do what the question asked. So, I would just like to remind the class in general that in your interactions with the TAs, the Student Code of Conduct is an applicable document. You're not actually permitted to, heap abuse on the TAs because they didn't remark your assignment in the manner in which you expected it to be remarked. So don't do that, basically. Mark has been extremely good to us and to me. He's been going well above the call of duty with respect to his duties as a TA, and like the fact that people would be, dickish to him about regrades is, to me, beyond the pale. It's really nothing. I would have expected much better from the people who are, taking this class, just generally as human beings. Obviously this applies to, a very small minority of the class. And if you are in that minority, you know who you are. But, yeah. It's, I just, to some degree, it's, you get out of the universe the energy that you put into the universe, and if you're putting, this type of negative, spiteful energy into the universe, that's exactly what you're going to be getting back out of it through one way or another. But, yeah. So, just, we're not trying to play dirty tricks on you. There were a number of people, to answer Hansen's question, if you chose a different pivots for quicksort, will the number of recursive calls be different? If you, we did have some instances of people who made slight alterations to the quicksort algorithm that altered the number of recursive calls, getting their question mostly incorrect because they, they messed it up a little bit, or they, chose a different pivot, or, did something that's, wasn't quite the question as specified, but it's still largely quicksort. Generally speaking, those, instances of those types of answers that we've been, having come across our desk, we've been quite generous with. Not necessarily full marks, but probably most of the marks in most cases. So, yeah. And, I understand that, there's some flex that's needed in the system, absolutely. But, if you're just, returning L.sort and expecting full marks from that, when I said specifically in the question that you're not going to get hardly any marks for that, then, I'm sorry, I can't help you. But anyway, I just wanted to talk to you guys briefly about that, even though that wasn't such a brief talk about that, because, I believe that Mark deserves better treatment than that, considering, he's not even assigned to answer questions on Piazza, right? That's two other guys are assigned to answer the questions on Piazza, but Mark just answers, something like 2/3 of the questions on Piazza, even though it's not his job, Anyway. Not that if any of you other TAs are listening, you guys are doing good jobs too. I'm not saying that Mark is the only good TA. It's just Mark definitely goes above and beyond, and I don't feel like he deserves the treatment that he gets when he gets treatment like that. So, anyway, I won't speak about it anymore. Anywho, so let's talk about exceptions. Exceptions, this is an important one for you guys to, With respect to testability, these slides here are going to be the primarily testable portion of this topic. It turns out that exceptions are a really easy thing to work into just about any problem, just about any question, including exam questions. So it's often the case that in order to test exception handling, I'll just throw, I'll take a regular question and say, okay, and if the inputs are wrong, throw a exception, something like that. But anyway, let's talk about what exceptions are. Let's see if we can get through this. So, suppose you want to create a function that returns the maximum number in a list. What should the function return if you input an empty list? That's a good question. Should we return 0? Well, no. 0 might be an actual valid element in the list. So you wouldn't want, like for example, 0 might even be higher than the maximum value that the list might return if the list is composed entirely of negative numbers. So 0 isn't really a good solution. Should we return infinity? Should we return not a number, which is some programming languages like JavaScript, I think, have an actual designation for not a number. This is a slightly better solution, but still not ideal. What about false? This has been sort of the way we've been handling improper inputs thus far in the course, is we've been returning false from the function. However, there's a sort of a problem inherent in that. Anytime you call a function that might return false, you need to check to see if it did return false. This is not good design. This is not good modularization. Generally speaking, when you write a well-modularized function, the user should not have to have any code attached to that invocation other than the invocation itself. There should be no strings attached. If the function might return false, and you have to check for that in the code that calls that function, that's having a string attached, right? There's this thing that you have to do in order to be using the function correctly. The function should be correct to use the function just by calling the function. That's good modularization. So, for example, if we had this function bound, which returns the max of L minus the min of L, if max or min were both returning false on an empty list, we would have to individually check both max and min for false values being returned before returning max minus min. Because if we take a look at our handy-dandy Python interpreter, what happens if we subtract false from false? We get 0. Is 0 correct? No. This actually has to do with the underlying binary representation of Boolean numbers. If we convert, for example, a true, I think maybe I can do this. What is true? True is 1. What is false? False is 0. So, if you subtract true from false, you get 1. But if you subtract false from true, or, sorry, the other way around, you get -1. This doesn't make any sense. This doesn't make any sense at all. What is, what is the can we even Boolean convert -1? That's true. So true minus false is true, and false minus true is also true. The point I'm trying to make is that subtraction as an operator doesn't make any sense whatsoever over Boolean data types. However, you will be forced into a position where subtraction will occur over Boolean data types if these things are returning false and you don't check for them. So, such as this situation. See how much clunkier this is? This is so much clunkier. This is so much clunkier, it might as well be expressed in C. Ho! Burn on C! Hey, but I thought the prof liked C. That's, yeah. Shush. Anyway. So, here's a question. What should happen when you pass a string to an integer conversion? Should it give a 0? Well, no, because that's a valid response if the string that you've entered is 0. False? That's not an integer either. So what does Python do if we try to integer convert something that isn't an integer? Potato. We get a value error. Value error is a type of exception. So, exceptions allow Python to deal with situations where it tries to execute a statement that isn't well defined or violates some condition. Python raises exceptions. You may raise an exception by typing raise and then the name of the exception. So if you want to create a value error yourself, you raise a value error. There you go. You can create problems. Ho-ho. So, an exception, as you guys will have known by now, interrupts the normal flow of execution. It terminates the program, typically speaking. There's a big ol' asterisk hanging off the end of that statement, though, and that asterisk says in the footnotes, as if that exception isn't handled. So, we're going to learn how to handle exceptions. There can be an exception handler, which attempts to recover from an exception, or the exception can be unhandled, in which case the program crashes. So, here is a... Here, let's, I think I'm going to do this in a file. I think that'll be easier. Code. Get it. Accept.py. So, let's define some function. Sure. Actually, we don't even need to do it in a function. Let's say doing too much C again. Print, enter a number, please. Actually, that would be an input. Input, enter a number, please. And we will save that to in. And then we will integer convert. In is equal to integer conversion of in. So this is retyping in to be an integer. And if we execute this, what do we get? Actually, you know what? Let me see if I can navigate to this because it's got big O vision. CD, doop. 1MD3, fall, code, there we go, Python 3, accept. I got a syntax error, invalid syntax. What? Oh, in is a defined keyword. So we'll call it shmoosh. There we go. Oh, yeah. I seem to be making things more difficult than they need to be. There. Enter a number, please. 6. Whoop. Shmoosh is not defined. Oh, yes, I am making things more difficult than they need to be. 6. There we go. Print. Your number is that, and we shall be just printing it. That's fair. 6. Your number is 6. So what happens in this program if we enter no? We get a value error. However, if we wrap this in something called a try except block, it's kind of like an if statement. If something inside of the try block causes an exception, program execution will immediately jump to the except clause and execute any of the code that's inside of the except clause, which you can say, well, I didn't want one anyways, so there. Enter a number, please. 8. Your number is 8. Enter a number, please. No. Your number is no. Oh, interesting. Well, that only really works because this is, this works on that as well. If I'd used a different variable, like shmoosh2, then that would... Actually, I should just put it up here. So, terminating. There we go. So, enter a number, please. 6. Your number is 6. Terminating. Enter a number, please. No. Well, I didn't want one anyways, so there. Terminating. So, this is how an except block works. If an exception is raised here, inside of the try block, we immediately go to the except clause, execute whatever is in there. Once we are finished, the program continues as normal. So we can then print terminating. The exception is raised when we attempt to integer convert something that is not an integer. However, rather than crashing the program entirely, we have code that handles that exception. That's why it's called exception handling. So there you go. And just to further make things interesting, you can actually have different except clauses based on the type of error that you get. So if you get a value error, you can do one thing. If you have a div, or say, what do they call it? An index error? L at 6. Index error, yeah. If you get an index error, you can do something else. And if you want to get the other, if you want to catch the, in all other cases, you can just do except with no type of error indicated. And it'll sort of look through these in the order that you present them. But it shouldn't really matter because the errors are sort of, you can only have one type at a time. Except if you put like an except with no error at the top, then that one's always going to be the one to execute. But yeah, so excepts, that's how you handle exceptions. Let's see if there are any questions. I'm sorry, Dave. I'm afraid I can't do that. If you are sitting in this audience and you have not watched 2001: A Space Odyssey, the time has come. Can we return nothing like in Haskell? You can only return nothing in Haskell if you're using a maybe type monad, and no. I don't, no. Well, I shouldn't say that so flippantly. There probably is a maybe type in Python because it's a very large and well-supported language, but this doesn't really have anything to do with maybe types. And while maybe types are can be used for something resembling exception handling in Haskell, they're really not, if that makes sense. Either types are also a fun one. What if the input is true? Okay. Let's try it. Probably you can't integer convert true. Oh. Okay. Get out of here, you. Pass. if you ever want code that, like a code block that you don't want to put anything into, just type pass. It's like do nothing, the instruction. So enter a number, please. True. Nope. That's not an integer, so it fails. There you go. Cool. Anyway, so the handled exception places the thing that might fail inside of a try block and creates an exception for the particular type of error. You should, if you're handling exceptions, you will want to put the code that might cause an exception inside of the try block. If you would rather the code just pass the error along, that's also a valid thing to do. Like, you might consider, if, you can imagine a situation where a function takes an input and calls another function, passes that input to it, and if that function produces an error, then the function you're currently writing would just pass that error along. In that case, you just don't handle the exception. But if you want the function to handle the exception, then use a try except block. Yes, so we talked about that. You can raise exceptions in your own code if it enters a situation your code isn't intended to handle. So, for example, find first even. Returns first even number in a list L. Raises value error if no even number is in L. So, for x in L, if x mod 2 is equal to 0, return x. Otherwise, raise value error. So, yeah, if you want to create an error, if you want to be problematic, you just call raise. Here are some common classes of exceptions. We've got index error. This is when you are trying to access an index in a list, a string, a dictionary, etc. that doesn't exist. So, as I showed you in the terminal, if you've got a 3-element list and you try for the 28th element, or 27th element, 0 indexed, then you're going to raise an index error. A type error is when you are trying to do something to, if you're trying to use the wrong operator on something. So, or your operands are of incompatible types. So, going back to our interpreter, for example, if we have a list, lists have certain operators that are good on them and certain other operators that are not. If we, if we use plus in a list context, that means concatenation, but concatenation is only an operation between lists. So, if we try to concatenate, for example, a tuple onto a list, we get a type error, because tuples and lists are of incompatible types. You would have to convert that to a list, and then it is, not a tuple. So there it is. Nope. All right. I think you put a comma there. Yeah, there you go. That's how you do a singleton list. Tuple. I meant tuple. There we go. All right. Value errors are when a function or operator is applied to an object of the right type, but it's otherwise inappropriate. So, for example, if you're converting a string to an integer, the input is of the correct type in the potato case, right? In the case of potato, like, there we go. In the case of entering potato, we have something of the correct type, right? Because we are looking for a string. It's just that the string has an incorrect value. A more mathematically rigorous way of saying this would be that the input is outside the domain of acceptable inputs. So the function is being applied outside of its applicable domain. So don't do that. That's an error. Not implemented error. So you guys will have seen not implemented errors quite a bit, because at the beginning of the course, Mark decided to have the he decided to configure Jupyter in such a manner that it placed not implemented errors in your code everywhere a solution is removed from a source block. So one of the things that Jupyter does in order to compile an assignment to be able to send it out to all of you guys is, believe it or not, in like our master copy of the assignment, we have solutions to all of the problems that we're asking you that are, inside of these solution brackets. If you remember from back when you guys actually got to see the feedback, you would have seen these solution regions. One of the things that Jupyter does when it generates a assignment for publication is it takes the solution block, removes it, and puts in something that we specify. Mark decided to put in raise not implemented error. You guys can actually delete those. I've been seeing a lot of people's solutions where they've just left the raise not implemented error in, which it's like a pass statement. It's designed to be removed. So there you go. We also have recursion errors. So if you exceed the maximum recursion depth, you will have seen that when we were doing the Fibonacci. The first Fibonacci, the non-memoized Fibonacci case, we were able to very easily hit the recursion number, or maybe we did that on factorial, I can't remember. But if you exceed your recommended recursion depth, then you get a recursion error. If you have some error, miscellaneous error that hasn't been classified otherwise, you get a runtime error. And if you divide by 0, you get a zero division error. It turns out that you can't divide by 0 inside of computers. That's just a rule of computers. That's 0 divided by 5. But if you do 5 divided by 0, you get zero division error. Zero division does not yield infinity in a computer. In like the nominal algebraic sense, if you divide by 0, normally you'd say, okay, that's infinity, especially if you were taking a limit or something. In a computer, infinity is not a number that can exist unless you have, like, decided that some particular arrangement of bits represents infinity, and you've integrated that as a, distinct value inside of your programming system, which some programming languages have, and in some programming languages, that's how you handle zero divisions. However, in Python, because it's C-based, and C will, have massive problems if you try to divide by 0, you are raising an error rather than returning an infinity. So there you go. And one final thing while we're at it, let's talk about assertions. So an assertion is just, it takes a Boolean case, and like an if statement, if that Boolean evaluates to true, then the assertion case does nothing. If it evaluates to false, then it raises an assertion error. So if 1 is equal to 1, then we do nothing, but if 1 is equal to 0, that's false, so we get an assertion error. Assertions are a primary mechanism by which the autograder test cases are written. So you probably have seen quite a few of these so far. So yeah. Anyway, useful for unit testing and defensive programming. Yes, indeed. So, yeah, any questions? Some questions. Do we need the comma if there's typecasting? Yes. Yes, we do. Because otherwise it doesn't consider it a tuple for some reason. Why Haskell has no recursion error? Because it doesn't need one. Haskell, the recursion depths that you would get to in Haskell are so immense and terrible and complex that if there was such a thing as a recursion error, you wouldn't be able to do anything useful. So Haskell just handles recursion better. I've seen way too many recursion errors when doing the assignments. That means that you probably aren't doing your base cases correctly. If your base case is good and it's catching on the base case, then you won't hit a recursion error. What is the value of the maximum recursion depth? I believe it's 5,000 by default in Python. Hey, are we done week 7? Yes! We are done week 7. We are on to next week, Tuesday. Today's Tuesday. On Thursday, we're going to start topic 8, which is about classes. So we'll have our classes on classes. Why do you get a recursion error? You get a recursion error when your maximum number of recursive cases is exceeded. So, I don't know, can I do this very quickly? Def factorial n if n is equal to 0, return 1, else return n times factorial of n minus 1. So this is a good test. Factorial of 100 will work. Factorial of 5,000 may not. We shall see. Yeah. So we get a recursion error, maximum recursion depth exceeded in comparison. So this is too much. And maybe this is not too much. Nope, that's still too much. Still too much. Is that too much? Is this too much? That's not too much. So, it seems the default is not 5,000, but 500? Yeah, Anyway, there's some number. It's defined in Python, and you can modify it if you want, but yeah. Anyway, I gotta get to my next class, so, does C have proper Haskell-style tail recursion? Only if you program it, sir. Only if you program it. Haven't seen Rimby in a while. Yeah, remind me about it on Thursday, and I'll be sure to grab Rimby. But she also just hasn't been around. I don't know. Maybe she's camera shy. Anyway, take her easy, folks. I'll see you on Thursday.